Right, good morning. What is it? 23 minutes until coffee. I'll try not to make you wait. For if you want to read along or ask questions on proxy hands, this is the code. This is the URL of the demo code. It also has the presentation. Then some caveats. I realized that I called my thing GenFPL, and it doesn't stand for general or generic, but for generate. Something to keep in mind. I was going to say it's in its infancy, but it's more like fetal stage. I heard some people saying, "Yeah, last week we did." Well, for me, it's not really last week. It's more like this morning in some cases. So let's first do a quick quiz. We'll also can call it market fit research or something like that if you like. By show of hands, who of you have developed a DSL? Okay, pretty much everyone. Keep your hand up if you can answer yes to, if you ended up implementing a functional programming like sublanguage, like expressions, things like that. Yeah, okay. And keep your hands up if this language was not really super domain specific. Yeah, that's more or less the same hands. that's very good for my market research. Yeah. Okay. Thanks. So what you see is you often the situation is you have a domain-specific language that has some size, and then you have this sub-language with all kinds of expression constructs that is actually at least as large as the original domain-specific language that you started out with. Right? Yeah, the people with the hands in question 3 can attest. Okay, good. Otherwise, we could go to coffee immediately, I guess. What is this GenFPL thing? It's a bit of JavaScript tooling in the Node NPM, probably also Dino works as well. And it's meant to quickly implement functional programming like sublanguages. You can find it here, and it's licensed under Apache 2.0. And of course, it's powered by LionWeb. It's probably not a surprise. So why did I do this? Well, I think, okay, we didn't have like the whole room with their hands up after the quiz, but at least some hands. So I think there is a need for, let's say, industrialized implementation of these kinds of embeddable sub-FPLs. Okay, we also have KernelF. But not everything happens in MPS. In fact, Arjan is the only one who has a talk with MPS in the title this year. So, yeah, maybe we're not all doing MPS anymore. Also, I wanted to showcase LionWeb, and I wanted to challenge some programming language research traditions. I was trying to get through this book. And hit some snags, and I thought, well, it would be nice if I could just make my own functional programming language. And I have all the tools and knowledge to do that. It's just a lot of work, so why not save everyone else that work? Well, for fun, at least for some values of fun, and well, yeah, it's a good topic for a talk, I think. So what are we going to do? Well, we'll get through that. Also, yeah, what is a functional programming language? Can have a long debate about that, but I like Marcus Fulter's definition. It's just a funclarative expressions language. It has a substitution model. It's easy to reason about. That also means that implementing things like interpreters, etc., is a lot easier than for general programming languages. So, an overview. Grab my laser. So basically, this is the tooling part of GenFPL. What is grayed out is not there yet. So we have a configuration language, which is of course defined in LionWeb, and with that you craft a configuration for your language. which is quite small, and then you run it through a generator, and it spits out a meta model for this function programming language, which is of course a LionWeb meta model, that hooks into a host language here. So you point from the configuration to this host language, and this sub FPL is then embedded in this host language, and you can use it from there. And what is also, at least at the moment, implemented or generated, should I say hallucinated maybe, to avoid confusion, is a default interpreter implementation, and you can extend that, and I intend to also generate a default type system implementation. At least I intended to until Johannes' talk yesterday, because now I'm thinking, oh, I just better hook up type here, and I certainly see possibilities there. And I also want to do some integration with Freun, specifically for creating generating a concrete syntax. Okay, got this? Oh, of course, it's powered by LionWeb. Some design. So we generate this sub FPL from a configuration. We generate a meta model, extensible default implementation of an interpreter. And there's lots of stuff to still do, but yeah, this morning ran out, so yeah, that'll have to wait. The granularity is, you can call it modules. I think I like the word areas a bit more. So I have a number of areas I identified in these kinds of languages. This is not backed by any research or anything like that. This is just my opinionated view of matters. We'll come back to this, but of course you want some primitive types like Boolean, strings, those kinds of things. Probably your host language has something along the lines of structured data types. You want to be able to hook into that. So here's the host language, and you want to hook into structured data types that are in there and do something with those. Functions, grouping of expressions, if statements in a functional way, obviously. Maybe a nil if you are feeling daring. Of course, lists and listy things. Faults and exceptions. Last year I had a talk about this at the Langdev, how you could do that. Unknowns, same talk from last year. Comments, and then there's a lot of other things that you can add. I think there's a bunch of people over there that like this bit maybe. Well, okay, so you have all these areas. And if you look at one area, you can sort of see a meta hierarchy, and that is you typically have a type. So you have a concept in your language for a type for that specific area, like structured data type or something like that. And well, in this case, I assumed that the host language already has like a super type for this type, but we can also generate it if you like. I didn't implement that yet, but that would be an obvious thing. Also, I assume that the host language already has a concept or an interface for value, like expression. If you look at KernelF, this thing is called expression, I think. Also, you could generate that if you chose to. So, for an area, you would have one or more types, and with these types are probably literals, which you would also like to generate. Like if you, we get an example in a minute. And then a bunch of operations. So as an example, this is the Boolean area. So here in the host language we have a value type, a type. We generate a Boolean type, and then a bunch of operations. Well, a literal and a bunch of operations, and all these things are Boolean values. Which happens to be a value as well. So this is predefined in the host language, and this will generate from the configuration. So a demo. At least yeah. So first off, we define the host language. This is a definition of a LionWeb metamodel of a LionWeb language in the TypeScript API for that. There are several ways to define languages in LionWeb. This is just one of them. From this, we can also generate like a nice plant UML diagram. So this is the very simple host language in this case. Here you see the value type, the type, and then we also have a record definition with some attributes, and every attribute has a name and a type. Okay, where's my configuration gone to? So here's my configuration, which is also a LionWeb model. We have some ID stuff. You have to give your sublanguage a name and an ID and a key. And then we point to the value classifier. So this is a reference to this value type from the host language. And likewise, this is a reference to the type from the host language. And then we have some other stuff to configure, like we want a Boolean area. Yes, I would like to, and we'll get to this in a minute. And then we can press the generate button. It will generate some stuff, and we'll get a meta model for the sub function programming language, which is persisted as JSON. That's this file, but I also generate a plant UML diagram. So this is the diagram. So this value is coming from the host language, and this as well. And let's see the other things. Not yet. But the rest is generated. So we see the Boolean value, the Boolean literal, some operations, and what else have we? Yeah, here the Boolean type. So that's all generated. What is also generated is this default interpreter. We start off with some, so here, sublanguage default interpreter. We start off with some boilerplate, and then this is the standard interpreter code. I use quite a bit of LionWeb reflection to get this working. But yeah, this is all generated for you, so it's easy enough. Let's see. Oh yeah, we can. So that's the default interpreter, and you can extend that. In this case, I chose not to extend it. I just chose to keep the implementation as is. And then I instantiate it, and I can define some tests with it. And actually, I can run them, and they pass. Yay! So let's get back to the presentation. So yeah, accessing records. As already mentioned, a host language often has facilities for data modeling, things like that. So you want to be able to hook into that and maybe do a dot expression and operations like that. So what we do, we extend the configuration. We point to these things in the host language, and we generate the appropriate concepts along for these. So as we have already seen, this is the host language. We have a definition for records, for their attributes and the types. And this is what we actually want to generate here. Yeah, then we have the second part of the demo. So And to be able to do that, I have to do a couple of things. Again, I have to point to things in my host language. So here is a pointer to the record definition of the host language, to the attribute. And then I have to give some names for what I want the record literal type to be. In this case, I chose record instance. And the same for an attribute value, which is going to be attribute value. So I already ran the generator, so we can just look at the meta model. And then we see, indeed, there's a record instance here. There's a dot expression operation now. And this dot expression is, well, yeah, we have a left-hand side, an operand, and a right-hand side, which is the attribute that you want to access. And this is, of course, a value again. This is added also to the interpreter so that you can actually execute this operation. I didn't write any unit test for that, also because it's not working right now yet. Right. Yeah, I think I have time for this discussion. So what a lot of programming languages do, like real programming languages out in the world, is they have a standard library, which is good, right? So the idea of a standard library is you have in terms of language engineering, you have a language, a meta model here, and you have a standard library. And the standard library is actually a model itself. It conforms to the meta model, but you just happen to refer a lot from your model to the standard library. The idea here is that you push a lot of your complexity away from your meta model towards the standard library. We see that with languages like Java and yeah, especially Java, that there is a small number of concepts in the language's meta model, but the standard library is huge. For Java, that's a very sensible thing to do, but it does come with a cost, which is no problem for languages like Java to pay. And the cost is that you need generic concepts to be able to define this standard library, including things like type system, etc. So you and the problem here is, or the challenge or consequence, unavoidable consequence, is that you sort of get an inner meta model for this. So is it always a good idea? There's a pros and cons for this. So the pros are obviously there's fewer concepts to deal with on a meta model level. So your interpreter or your generator is probably a lot simpler. It's more malleable. You can do updates more easily because you just have to push the standard library. You probably also get better abstractions, generalizations. We have seen that with functional programming languages like Haskell, where if you try to push abstraction all the way, you might end up with pretty powerful stuff, right? There's also, if you confine yourselves not to general programming languages for developers, but for example DSLs for actual business users, there's a clear set of cons. The first thing is that everything is going to look the same. I mean, if you look at Java standard library, everything just looks the same. It's just a function somewhere or a method on a class living somewhere. So there's no syntactic difference. The discoverability is, I think, also worse because you just have to find this thing and you can't distinguish them on syntax. So that's not necessarily a better experience for the user of the language, which again for a developer might not be so much be a problem, but for an actual DSL user, a non-developer, that would be a problem. Also, you burden your type system quite a bit because, well, your type system has to understand that it has to look up, okay, I'm referring to something in the standard library. maybe I have to infer some types there, do some generics, things like that. So things do get more complicated, and you see that in languages like Java, or especially a language like Scala, where this has been like pushed to the limit. And often the developer suffers in terms of error messages and things like that. So for GenFPL, generation is cheap, cheaper than hallucination, apparently. So all the advantages of having a standard library pretty much disappear, while the disadvantages are still there. So I chose no standard library. If I have an operation for, let's say, an array, I will just generate a concept in a meta model for that, and not have like a generic concept for list operations in the meta model, and have a standard library backing that. Okay, 2 minutes until coffee. We'll manage. So I found this interesting to do, because it sort of pushes you to go one meta level above again. You're not just making a meta model, but you're sort of making a, well, sort of disconnected meta model, and you have to think about how do you hook into this host language, because you just have to hook into that. You can't make any demands about what the thing will look like beyond, okay, there has to be a classifier that represents types, and there has to be a classifier that represents values, or I will generate that for you. Yeah, so the resulting language is pretty simple, just because you can generate it in a form that is most suitable for your users. It's a good inspiration for LionWeb. It's a good way to find bugs and things like that. There's also plenty of work to do, obviously. So this is a short list, let's put it that way. First priority would be integrating with Freun. Implement more of these areas. So there's now like 2 or 3 areas that I implemented. I want to do the whole screen. A CLI would be nice. Actual type system, so I'm looking very much at type here and integrating that. It would be nice to have a UI for this configuration, so that you just can click together this configuration. And an idea that popped up yesterday is maybe instead of generating an interpreter, generate a generator. Was your idea, also for performance reasons. So, any questions? Nico.
So you inherently accept that you have historical dependency between the host that the generated function.
Yeah.
It seems like a build language.
Could be. We'll find out.
It seems everybody wants coffee. Oh, another from Nico.
There was
Pedro was here. Pedro.
Okay, I'm thinking about the host language where you were building all of this. You are targeting Meinte TypeScript or C# or is agnostic, and then you can use later on any of the technology you use. I see that's a model we can reuse, but if there are some parts you need to implement in a library or whatever, you definitely to have different porting to different.
Yeah, well, the basis is LionWeb. So GenFPL targets host languages defined in LionWeb. That's the basis. So you can do, well, yeah. Right now I'm generating TypeScript, but yeah, you could.
But there is no dependency in TypeScript, I mean.
Not
Java or any other thing.
No, not specifically beyond that. What we're generating is TypeScript, so the interpreter is TypeScript. But yeah, it's just as easy to generate a C# or Java interpreter, and the LionWeb stuff is all the same. So yeah, as soon as the host language is definable in LionWeb, you're good to go. Yeah.
So on one hand, all those expression language are very similar.
Mm-hmm.
On the other hand, I always end up to extend the expression language with some concepts which are specific for the domain. So specific operators or units, which are very important for a certain domain. So whether you talk about money or milliliters or something like that. Of course, that also relates to the type system. How do you think about supporting that? Is that just manual additions to the generated meta models, or is that something that you, how do you?
My political answer would be hopefully not, as in I would hope to be able to do that in a non-manual way.
Yeah.
So to drive that from the configuration, or provide good extension points in the generated code. You saw that the interpreter was generated, but also extensible just by overriding the method or methods in that class. But I'll have to find out how that works exactly, and there will probably be situations that I can't cater for.
If you have something like that.
Yeah. Well, type
You
access.
actually also need to tailor it to
Yeah.
the domain.
Yeah.
It's both.
Yeah, well, otherwise you got your domain there and you got the expressions there, they don't connect, and that's definitely.
Yeah. Well, yeah. One inspiration was KernelF, because KernelF works great in one way, but it's a lot in one go, and you can choose which modules. But these modules are quite large as well, so you drag in a lot of stuff at the same time, and via configuration you can at least potentially be much more fine-grained in what you want to add. So yes, I want booleans, but no, I don't want integers, I don't want strings or something like that. So that was the reason why I started this. Just have the sub FPL that you like to have, and then extend from there maybe, and not drag in too much and then have to cut it away again in certain ways.
Use KernelF, you would have your own concepts in your own DSL inheriting from the expression in KernelF. That would be the solution in that context.
Yeah. Yeah, here it's more or less the other way around, because either you generate this expression, this value classifier in this type classifier, or you just point to those things in a host language if you already had them. So you have choice there.
To my understanding, I can use your work to add semantic to my LionWeb language. Is that correct?
That's correct, yeah. I think it's time for coffee. Thank you very much.